This is my Lego clock. I started building it in last summer, and it's taken a while for it to get everything. When I started it in the summer, it just had the hands, and then I added the day of the week dial, and then recently I added the AM PM indicator and the moon phase indicator. But it's got an auto winding mechanism and a pretty simple escapement. No knife edge escapement needed, it's just a regular pin, which really surprised me when I made it. It was almost by accident. So the weight here, it's these, I don't know, tank pieces that are filled with a whole bunch of these steel ball bearings. So it's pretty heavy. And there's also a bunch more in the back to keep the clock from falling off the mantle. And it winds around this winch, and when it gets to the bottom, this white string will pull up through that loop, and it will pull down and turn the motor on. And then when the weight gets back up to the top, these little spacers will push against the lever and push the lever. So it will turn on, and then that will push the motor off when it gets to the top.
And the motor does what?
The motor, if we come around to the side, the motor turns this differential here. It's not a standard differential because at the time I built it I didn't have any. But the motor turns the differential and it winds this up while still keeping the escapement running.
And then that raises the weight.
Yeah, weight goes up.
Rewinds the weight.
Weight goes up.
So it's self-winding.
Mm-hmm.
Okay.
But anyway, the pendulum is 1.5 seconds. So this 8-tooth escape wheel times 1.5 seconds takes 12 seconds to turn around. And then this 12 times 5, there's an 8-tooth gear behind that. This is the second hand. And then you may not be able to see it quite easily, but if there's a 36-tooth gear meshing with the 12-tooth gear on here, so that shaft takes 3 minutes to turn around. And then it'll be even harder to see, but there's another 8-tooth gear back on the end of the 36-tooth gear shaft that through an idler gear meshes with this 40-tooth gear right here, and so this shaft along with the winch takes 15 minutes to turn around. And that also turns this chain in the back that goes up to the top part of the clock, and then this through this gear, these gears here, and the universal joints. This universal joint shaft takes half an hour to go around, and then this white clutch gear takes 1 hour to go around, and that's the hour hand. And then the power splits. Half of it goes through this gearing inside these frames that's linked to these two turntables that turn the hour hand 1/12 of the way around. I had to use another turntable to do that because I don't have any of the new 28-tooth gears. And the other half of it goes through this worm gear and the 24-tooth gear that then takes 1 day to turn around because there's 24 hours in a day. And half of it goes to the AM PM indicator. If it's down, it's PM. If it's up, it's AM. Like sun up and sun down.
Where is the AM PM indicator?
This little red,
okay.
Yeah. And the other half of it turns this second 24-tooth gear, which takes 3 days to go around, and then comes over here down to the back, and eventually ends up turning these 12-tooth gears, which again take 3 days to turn around.
Okay, your hand?
3 days to turn around. And then this turntable here is, of course, 12-tooth to 28-tooth. That's a 3-to-7 ratio. This turntable takes 7 days or 1 week to turn around.
So
that's the day of the week indicator. And then the moon phase indicator, the moon takes 28 days-ish to change phase. So what I did is I attached a worm gear to the back of the day of the week indicator and attached a 28-tooth gear to that. So this gear and shaft in the back takes 2 moon cycles, or 56 days to turn around. And then I attached a 1-to-2 ratio to reduce it down to 28. And you can see right now it's about 2:40 in the afternoon on Sunday.
And that is correct.
And wax and gibbous.
And that is also correct. Nice job. And we've been listening to your clock wind and tick and using it to tell time for 6 months or more, and it's works pretty well.
Yeah, I just noticed when I came back up here, right around this little red brick next to the gear here, there's this little amount of red Lego dust that I just blew some away with as I spoke. I don't know where that's coming from, but it doesn't look like it's causing a problem.
No, works pretty well. And so now you are getting ready to
Take it apart.
Take it apart and do what?
And I'm gonna
take some of it apart.
Yeah, second version of it that has standard Lego differentials, so it will be it will wind better. It's got a better winch, so that the string doesn't get all munged up on here, wound really not neatly. It will also have a hour strike and all of this, and it will have virtually no Lego bricks, all Technic.
Okay. But the big addition is the chiming
yes.
mechanism, the hourly chiming mechanism that
Yes.
you've been working on.
Mm-hmm.
And you've shown that to us, and it looks like it's going to work pretty well. So you just have to test it out, put it all together and test it out.
Mm-hmm. It will use the same weight. So I'm just going to stop
Which is
it.
taped together because it did fall one time and
a couple times
crash onto the...
a gear in the back came undone and allowed this weight to free fall, and
in the middle of the night.
In the middle of the night, and it fell down, and the marbles in this
Popped
outside
open.
burst out, and there were marbles over there, there were marbles over there, there were marbles behind Mom.
Yes.
And
it kind of scared us in the middle of the night. Huh?
Yeah.
What is that racket?
We thought the cat had knocked something over.
But all is well. Just a little bit of tape fixed that problem.
And
that was
fixing
really
the gear.
never needed again. You adjusted the clock and it never fell again.
Yeah.
But just in case.
One time the gear came undone, the little idler gear in the back, I had it on one of those little tan pins, and it had a habit of popping itself off the pin and coming disengaged. So I attached it on an axle with 3 half bushings on the back so it couldn't slide out. The other time it was this 8-tooth gear attached to the differential that got the little red piece right here that's holding it onto the differential pulled out, and it came disengaged and the differential turned around. But I fixed that both.
Fixed that.
And the escapement, it's cannot be recreated using Technic bricks, so there is Technic beams only, so there is going to be at least one Technic brick in the new version. And the reason why is because there's this Technic brick that holds the 2 gears, and then there's one brick in between them and another Technic brick that holds the pendulum. And if I hold this, I can figure out how to hold it. If I can hold this beam here, actually I'm just going to stop it to hold this beam here. You can see that it's not exactly 2 studs, it's a little more. I tried 2.5 and that was too much. But it's not an even number of studs that can be created using only Technic beams. So I had to use bricks.
There you go. A very, very, very nice Lego mantle, pendulum, self-winding.